Student, till now we learned how that LPP will apply in our real life. I have taken an example of round type biscuit and rectangular biscuit. We learned what is the meaning of LPP, what are the three parts of an LPP. Then how that LPP came into existence, what is the historical background we learned. Student, now our main work is how to formulate the LPP. There are only two types of problems involved. Problem point of view, formulate LPP, bring into a mathematical model, then you have to solve an LPP. Now we are discussing about formulation of an LPP. All of you write in your notebook, formulation of LPP. We have to formulate the given LPP. So this is all what you learned, you call it as concept 1, background about LPP, concept 1 till now. Concept 2 is about formulating LPP. Concept 2, formulation. Students, how do you formulate LPP? How do you write the given details into a mathematical format? For that LPP, I have already told there are three parts. Part 1, objective function. Part 2, structural constraints. Part 3, non-negativity constraint. Considering this, you have to formulate an LPP. Since it is an important chapter, we will take first problem, we will understand properly how exactly the three parts of LPP can be worked out. Then once you understand, then later part will come how do you solve LPP. Let us look at problem number 1, classwork problem 1. As per that question, it goes this way. A firm manufactures two types of products, A and B, sells at a profit of rupees 2 on type A, 3 on type B. So, two products are there. A if you sell 2 rupee profit, B if you sell 3 rupee profit. Second line, each product is processed on two machines, that is G and H. Type A requires 1 minute on processing through machine G and 1 minute on machine H. The machine G is available for not more than 6 hours 20 minutes, whereas students, all of you go to the problem number, classwork problem 1. So, refer the relevant page. Problem number 1, a firm manufactures two types of product A and B, sells at a profit of rupees 2 on type A, 3 on type B. Each product is processed on two machines G and H. Type A requires 1 minute processing time on G, 2 minutes on H. Similarly, type B requires 1 minute on G and 1 minute on H. The machine G is available for not more than 6 hours 20 minutes, while machine H is available for 9 hours during any working day. Formulate the problem as LPP. So, all of you read the question again. What are the details? We have two products, we have the profit details. I will write here. The details given to us is there are two products. Products are A and B. They given you profit on each and the processing time required for A and B, which they are given how much machine G and how much H. That means to produce the product we need to have two machines G and H. So, we need to know how it is given in the question. So, let us write down all the details given. Product A and B. Profit on each is given and it passes through, it requires through machines, machine G, machine H. They given how much for machine G and machine H for product A, similarly for product B. With these details, you have to formulate the given LPP. Student, let us write this way. So, how many units of product A? Product A we do not know, we will take X units. Number of units of product A and product B will not be given. Entire LPP solving will give that answer. That is what we call decision variables, unknowns. We do not know, finally that is what I told you in that earlier example, round type and rectangular type biscuits. With all solving LPP will come to know round type how many biscuit packet, rectangular type how many biscuit packet. Student, we do not know the number of units. We have to assume some numbers. We will, since they are unknowns, we will take X, we will take Y. So, product A X units, product B, the next product is Y units. You can take x1 and x2, we will take x and y units. So how do you write that LPP? Let us do like this. All of you write a box. So you write why this box is about. We need to write that all the given details, that whole story, you have to bring into mathematical model. To bring into mathematical model, we need to work out like this. First we will write name of the product, which is A, which is B on other side. Number of units. Students, you tell me whether number of units will be given? No, by solving you have to know what is how many units of A, how many units of B. It will not be given. You have to take X, you have to take Y, which I have already considered above. Then profit per unit. 1 unit if you produce and sell, 2 rupee profit. Refer the question, A 2 rupee whereas B 3 rupee profit. Next we need to know, students, always you have to remember product here to produce what you require. Here you require 2 machine G, machine H. Always the requirements are like this. Example, in one problem given, to produce a product you need to have 3 process: grinding, polishing, finishing. All this you have to write this side. So products here, to produce the product what you need, what is ingredient, what are the processes, what are the materials, so that the product can be produced, that will come here. So that's clear. So in this case you need 2 machine help, machine G, machine H. This much is understood. Now our next step will be product A. Let us put a downward arrow mark. Product A requires how many minutes of machine G? Read that type A requires, all of you read the question, type A requires 1 minute processing time on G, 2 minutes on H, not A and B. A requires 1 minute here, 2 minutes here. To make that product A ready, it should pass through machine G, first machine 1 minute, it should go to machine B, there 2 minutes, then the product A will be finally output. Same way, product B requires both the cases. Let us look at this way, 1 minute, 1 minute. Don't take A and B, A 1 minute, 2 minute, B takes 1 minute, 1 minute. Now, to formulate LPP, observe carefully, the profit I will take Z. Profit, what you will, profit, cost, investment, whatever, you take Z. Now you tell me whether you want to increase your profit or decrease. Is it maximizing or minimizing? Obviously your answer will be maximizing. So I have to write Z max. Both profit put together, I have to get highest profit. How do you consider? 2 rupee profit for product A, 1 unit. If I produce 10 units, it will be 20. If I produce 500, it will be 1000. This profit and this profit I have to increase. 1 unit 2 rupee, 10 unit 20, there are x units you are producing, it will be 2x rupees. Some answer we don't know. Similarly, here 3 into y, 3y rupees. This is the profit on product A, profit on product B, total profit. That profit should be maximized. Part 1 done. Students, call this as 1. So 1 means always a standard one. Always we take objective function, need not to write it again, objective function. Whenever it is 1 is denoted, it is always objective function. Subject to 2, to produce this particular 2 types of product, there are constraints. What is the first constraint? After objective function, our work is to write structural constraint. We are into second one. How do you write structural constraint? Observe carefully. 1 unit of product A, 1 minute, 10 units means 10 minutes. If there are x units means how many minutes gone? 1x minutes gone. This is on machine G for product A. Similarly, 1 minute on product B, if there are y units, it will be 1y minutes are gone. I don't know how much x, how much y, accordingly so much time is gone. So 1x, 1y. So what is 1x? Machine G time for product A, machine G time for product B. But last part of the question is given, machine G maximum time available is 6 hours 20 minutes. Read that word the machine G is available for not more than 6 hours 20 minutes. Not more than means what? Highest is 6 hours 20 minutes. So, I should write here it is highest 6. This is where students will go wrong. Should I write equal? Should I write greater than or equal to or less than or equal to? If it is exactly equal to, then it is no problem, write equal. Here it is not more than, it is maximum 6 hours 20 minutes. Highest time you can take is 6 hours 20 minutes. Any time less than that it is okay, but not more than that. Therefore, I can say less than or equal to 6 hours 20 minutes. Student, you cannot consider in hours. Reason, this is in minutes, this is in minutes, whole answer should be in minutes. If you write 6.20, you are wrong. Reason, this is in minutes, total it will be in minutes. How can write in hours here? When this question came in previous exam, student used to write 5, 6, it is in hours. Convert into minutes. 1 hour is 60 minutes, 6 into 60, 360 plus 20, 380 minutes. What you are concluding in this structural constraint is machine G, both product put together, A and B put together, maximum time is 380 minutes. Maximum, any time below 380 minutes okay, 5 hours 300 minutes okay, 2 hours okay, but more than 380 is not okay. Therefore, less than or equal to 380. Same way, you should take the next one. Can you write for machine H? 2 minutes for 1 unit, 2x similarly plus 1y. The total available time maximum is how many hours for machine H? Question says it is 9 hours. 9 hours, but into minutes if you take 9 into 60, 540. This we will call 2. What is this 2 is about? This 2 is about structural constraint. So, objective function done, structural constraint done. Any LPP has how many parts? 3 parts. Objective, structural, non-negativity. What do you mean by non-negativity? Number of units what I have taken A and B, I cannot make it negative. I can make it 0. That is okay. No production 0. Positive okay, negative not okay. So, negative should not be there. We will write x comma y greater than or equal to 0. So, LPP is, see here last one, x, y greater than or equal to, it is equal to or more than equal to 0, okay. So, linear programming problem for given situation is 3 parts, z max 2x plus 3y, that is all, no equal, no greater than or less. LPP has 3 parts finally, z max equals 2x plus 3y, one standard denotation objective function, subject to 1x plus 1y less than or equal to 380, 2x plus 1y less than or equal to 540. It is always the standard 2 here represents structural constraints. Finally, subject to xy production units cannot be less than 0, it can be greater than or equal to 0. Equal to 0 also okay, greater than. Positive okay, 0 okay, but there cannot be negative units, x, y greater than or equal to 0. So, we learned LPP has 3 parts. How do you work out? Take x and y, formulate in a mathematical model. So, students will go for next problem in this. Students, now we look into the second problem. Problem is about diet problem. There are 4 food products, food A, food B, food C, food D, or product A, B, C, D. All these 4 products has 3 ingredients: proteins, fats, carbohydrates. So, product A, it has 3 units of proteins, 2 units of fats, 6 units of carbohydrates, and product A will cost 45. Same with B, C and D. Minimum requirement 800 units of protein, 250 units of fats, 700 units of carbohydrates. Now, what is our work? If you read that question properly, we need to know how do you formulate the given situation in LPP form. These are all the details given. Let us re-look into the question before solving. A person wants to decide, all of you refer problem 2, refer the relevant page, problem 2 LPP. Person wants to decide the constituent of a diet which will fulfill his daily requirements of proteins, carbohydrates, fats and carbohydrates at minimum cost. The choice has to be made from 4 different types, that is A, B, C, D. Since they are given all these details, we need to find out how do you formulate LPP considering cost into account. Students, you have a table with you all about food and the ingredient protein, carbohydrates and fats are there, all are given. How do you work out? First question, whether we are working out for protein, fats or carbohydrates or about ABCD. Food products are ABCD. Like last problem we have done product A, product B. Here the product A, product B is given vertically. For that, not the profit, not the income, but the cost is given. B cost is 40, C 75, D is 60. What we will take is, assume the food A x1 units, x, y, z. If I write, then again I have to go for A. Better I will take x1, x2, x3 units, x4 units. This is all the question detail. Let us solve it. Write in your notebook solution problem 2 diet problem. If at all all these are written, under that you write. First, how do you start with that? Our work is, what is the detail given? Food A 45 rupee per unit. We need to consider protein, fats, carbohydrates and reverse. So, we will write A food here, food product A, B, C, D. Cost per unit we will write. Student, can you tell cost per unit? It is 45. Always product here, ingredient this side, which I discussed in the last problem. So, 45, 40, 75, 60, this is given, and number of units not given. There is nothing that you have to write cost first, you can write later also. Previous problem are written number of units and profit, it is okay. However, number of units should come, it is x1, x2, x3, x4. Now, these all 4 products has 3 ingredients mainly. One is proteins, fats, carbohydrates. Product A downward, product A requires 3, 2, 6. Similarly, product B requires 4, 2, 4. Product C requires 8, 7, 7. Finally, 6, 5, 4. And what is the maximum or minimum? The requirement here is the minimum requirement. Protein, all 4 products put together, the dietitian would like to have minimum 800. Please note the word minimum. If this word is not properly interpreted, you are wrong. It's because the sign changes, entire answer changes. Minimum requirement 800. The least is 800. More can be any number. Starting number is 800. Whenever is minimum, tell me a number minimum of 800. Can you say 810, 820, 850, 900? Yes. Can I say 750? It is not minimum. Whenever you have minimum, I should use greater than or equal to. Therefore, we will take one by one. Minimum requirement, minimum here protein, whether it is A, B, C or D or combination, minimum is 800 units, 250 units, finally 700 units. How do you write this in mathematical formulation? Students, I will take like this. LPP is, you have to write like this. LPP, linear programming problem, is Z equals, can you tell how do you formulate? Z can be revenue or cost. In this case, cost. One product A, 1 unit, it will be 45 rupee cost. 10 unit means 450. 500 means 500 into 450. Like that, x1 units, it will be 45 x1 plus 40 x2 plus 75 x3 plus 60 x4. This is the cost in product A, food product A, food product C, B, C and D. All put together total cost. Students, you tell me cost should be increased or decreased. Always the cost, your money you are spending should be minimized. I will write Z minimum. We will call 1. Students, can you tell what is 1 is about? 1 is always the standard objective function. Subject to, how many constraints are there? There are 3 constraints. First one is about protein requirements. 1 unit, this is all for 1 unit. 1 unit requires 1 unit of food product A. 1 food product A requires 3 grams, let us assume. Then if there are 10, it will be 30 grams. If there are x1 units, then I have to multiply this, it will be 3x1 units of protein A. Similarly, in food product B, how much? 4x2 plus 8x3 plus 6x4. These are all the protein requirements. Now, all the products put together, protein requirement is the minimum 800. I told you many a times, underline the word minimum. Least number you have to get is 800. So, whenever you say minimum, that or more, I can write greater than or equal to 800. Whenever I say maximum, that or less. Example, what is the maximum marks you can score in the examination? 100. So, your marks is always 100 or less. If I say minimum you have to score in your PU board to pass the examination is 40, if I say 40 or more. So, the least is 40. So, minimum is always greater than or equal to, maximum is always less than or equal to. Keep this in mind. So, this is about proteins. Tell me fats contents. So, similarly 2x1, students, I think you can write this also, 2x2 plus 7x3 plus 5x4. All put together, the least fat content should be 250. Last one, 6 into x1, 6x1 plus 4x2, 7x3 plus 4x4, it should be least 700. This we will call 2. Subject to last one. Can there be any negative units? Definitely no. Non-negativity constraint x1, x2, x3, x4. Number of units of food product A, B, C, D. I can consume some number of food products A or 0 if there is no food, but cannot be negative, that is greater than or equal to 0. It is 3. First objective function, structural constraint. That means here for a dietitian, the ingredients are protein, fats, carbohydrates should be least this. That is a structural constraint. Non-negativity constraint, the number of products x1, x2, x3, x4 cannot be negative. It should be greater than or equal to 0. Students, we completed 2 problems. One was a production, profit was given. Here it is a cost. Note 3 areas where you go wrong. Area 1, have you written Z minimum, you check it out. Area 2, minimum requirement is there or not, you have to check. If it is minimum, it is greater than or equal to. Finally, you have to write all the 3 in a proper objective, structural, non-negativity constraint. All the 3 areas properly you have to record. Students will go for next problem.